isotopes. Okay? And by isotopes, I mean the average isotopic mass that we just did. And I posted the lab quiz for you, so you can do that. Just get it done by Friday. Okay? It's 5 questions on average isotopic mass. Now, we're going to move on to our second I word, which is ions. Okay? And ions, when we have, this is red, and we are on 923. Okay? Ions are different than isotopes in that now we're going to start changing the electrons. And we don't know much about electrons yet, but if you have a reference table in front of you, it's going to be helpful to look at the periodic table. Okay? So let's take out a periodic table. Why does it say oops? That's not a good thing. Oh, that's better. We're going to focus on this carbon for now only because it's big and it's in the middle and we can see it. Okay? Do you remember where we find the electrons in the atom? What is it called, or where is it that we find them? In the orbitals. Okay? And then that was the modern model, or the quantum mechanical model, where we say we find them in these orbitals. We're going to take a step back in time. We're going to go to the Bohr model of the atom. Do you remember what the Bohr model of the atom was called? Started with a P. Planetary model. The planetary model. Plum pudding was J.J. Thomson. So the planetary model, and it kind of looks like this. You're going to have a nucleus in the middle. Ooh. Red. Where's red? What's going on here? You're going to have a nucleus in the middle. And what's in the nucleus of the atom? Protons and neutrons. And then on the outside, that's where those little rings come from, you're going to have orbits in the Bohr diagram. Now, on those little rings, that's where the electrons are living. Okay. How many electrons are in each ring? Well, that's the great mystery of science, right? So each of these rings is called an energy level. N equals 1, N equals 2. Okay? Who has more energy? N equals 1 or N equals 2? 2 has more. And if there was 3, if it was 4, it was 5. And I'm going to diagram my little electrons with little red dots. E minus. That's going to be this. That's going to be my electron. Okay? Well, when we look at carbon, carbon has 6 protons in it. How many electrons is it going to have? 6. Because in an atom, the number of protons is equal to the number of electrons. Do you remember that? Okay. Now look at your periodic table. You see this down here in the bottom left-hand corner? It says electron configuration. You don't have to memorize the electron configuration because the electron configuration for every element is given to you. You see those 2 numbers right there? The first number represents how many electrons are in the first energy level. And the second number tells you how many electrons are in the second energy level. And if there were 3 energy levels, then there would be 3 numbers. I'm going to zoom out just a little bit for a second so I will show you something that's really cool about the periodic table. Okay? Carbon is in this second row. You see this 2 right here? Okay? That row is called a period. That's why this is called the periodic table, because this is period number 2. And then the third row is period number 3. And the fourth row is period number 4. And that one up there is period number 1. Okay? In period number 1, how many energy levels do the electrons have? Do the atoms have? Go ahead, Alex. 1. In period number 2, how many rings or energy levels do the atoms have? 2. In period number 3, they have 3. And in period 4, they have 4. And in period 5, you have 5. Holy cow, can you believe the coinky-dink? It's just unbelievable. It is. It's crazy talk, right? Okay. So the periodic table is a repetitive table. It is periodic, right? January, February, March, April, May, June, and then we start all January, February, March, April, May, June. It is periodic, and it is happening over and over and over again. So now, if you look at the first ring of the periodic table, right there, that first period, and it has 1 energy level, n equals 1, how many electrons maximum can I fit into that energy level? Well, this has 1. How many does helium have? 2. So that first energy level can hold maximum of 2 electrons. The hydrogen only has 1 electron, 1 proton and 1 electron. So that hydrogen only has 1 electron in its first energy level. But when you get to helium, you get 2 electrons in that energy level. Now, it starts the second period, right here. And we start a new ring to put electrons in. So that first energy level is pretty darn small. See this ring? It's the smallest ring that we're going to draw. And it can only hold a maximum of 2 electrons in that first ring because it's small. Now the second ring is a little bit bigger. How many electrons maximum can I hold in the second ring? Well, lithium has 1, and then beryllium has 2, and then boron has 3, and then all the way up to neon, which has how many? How many? How many in its last ring? In the second energy level? Well, the first ring is filled with 2. The second ring has 8. Okay, so the second ring gets filled when you get to 8. Okay, that's what I'm trying to show you. Now look at the third ring. The third ring starts at sodium. Okay, now the third ring is 1. Magnesium has 2. The third ring gets here to 8. Okay, and then it starts over again. Now, it gets a little bit tricky. Sean, put it away. It gets a little bit tricky because the third ring can actually hold 18 electrons. It doesn't really show it to you here until you get into the fourth ring. And the fourth ring, look what happens to these energy levels. So calcium, you see how on the third energy level there's 8 electrons? Look what happens when you get to scandium. Where does that next electron go? What ring? The third ring. Okay. This is called electron overlapping. And what happens is the electrons start to fill the fourth energy level, and they're like, oh, wait, there's some room on the third. And they go and they start to fill the third energy level. And the reason for that is because the third energy level is lower in energy than the fourth, so they'd rather be in the lowest energy level possible. All right, let's simplify this now for those of you whose brains are just like, what the heck just happened? Okay, I'm going to take my carbon atom again. In the carbon atom, I have 6 protons. Does everybody know where I got that from? Right here. Okay. We also know that it has 6 electrons. In the first energy level, how many electrons do I have? 2. I'm going to draw them. 1, 2. There's a party out there we weren't invited to. Okay. It is sad. We have to have our own party in here. Okay. Now, the second energy level, how many electrons are going to be there? 4. 1, 2, 3, 4. Okay. Why did I draw the first 2 electrons as far away from each other as possible? Why do they want to be equally spread out? Dylan? Exactly. They're the same charge, so they want to repel each other. So I drew the 2 electrons as far apart from one another as possible. Now, for every other ring, we are going to draw them in a clockwise rotation. Okay, we're going to start at the 12 o'clock, then we're going to put one at the 3 o'clock, the 6 o'clock, the 9 o'clock. That's 4 electrons. If there were more than 4, we would rock around the clock again, right? And we would go 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock. I'll show you that in a second, but I want you to digest what just happened in your head. So do you understand how I just drew this carbon? Okay, let's draw nitrogen. Nitrogen has a nucleus, and in the nucleus you've got 7 protons. I'm leaving the neutrons out. In the first ring, how many electrons do you have? 2. So I'm going to put 1, 2. In the second ring, the second energy level, these electrons now have more. That actually is a pretty good circle. These electrons have more energy. How many need to go in this second energy level? And how do you know? 5. You look right on nitrogen. It's up there. It actually is peeking out of the corner over here, right? Okay. In the first energy level, you have 2. In the second energy level, you have 5. 1 at the 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock. That's 4. Where does my next one go? 12 o'clock. Okay. Now, I will tell you that every once in a while you'll come across a question where they start at the 3 o'clock and they go 3, 6, 9, 12, 3, 6, 9, 12. It's okay. Or they start at the 6 o'clock, 6, 9, 12, 3, 6, 9, 12, 3. But once you start going, you should keep going in the same direction. Okay, why does this happen? Why do they double up like this? Well, it gets into some deeper chemistry, and that deeper chemistry is that one electron is, they're both negative, but one's spinning clockwise and one's spinning counterclockwise. Way above the scope of this class, so we're not going to go into why that actually is happening. Okay, so that's how we're going to draw them. Let's draw chlorine. Here's the nucleus of chlorine. How many protons does it get? 17 protons. Okay. I'm going to draw n equals 1, which is the first energy level. I'm going to draw n equals 2, which is the second energy level. And how many does chlorine need to have total? How many energy levels? 3. So we're going to do n equals 3. Now we can go back and we put our electrons on. Okay. In the first energy level I have 2. Uno. Doso. That's Spanish. Okay. It's not Spanish. Alright. Then I'm going to do how many in the second energy level? 8. 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock, and then 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock. See how they look nice and purty like that? Nope. It doesn't matter. Okay. And then how many are going to go in this last ring? 7. So we're going to do 12, 3, 6, 9, 12, 3, 6. Okay. So this is what we call the Bohr diagram. And it happens to be for chlorine. Okay. It is still an atom because the number of protons and the number of electrons are equal to each other. We haven't dealt with ions yet. It's still an atom. Okay. I want to give you a formula. I have to turn this just a little bit. Okay. So, when n equals 1, that's the first energy level. The maximum number of electrons that you can fit in that particular n equals 1 is how many? How many electrons can you fit in the first ring? 2. Okay? In the n equals 2, what's the maximum number you can fit? 8. In the n equals 3, the third energy level, the max you can fit is 18. And in n equals 4, which is as high as I'm going to go, the maximum you can fit is 32. There is a formula for that. It is not given on your reference tables. They do ask every once in a while for that formula. So I'm going to give it to you. It looks like this. 2n squared equals maximum number of electrons in the energy level, where n is the energy level. So if you think about it, if n is 1, 2 times 1 squared, that's going to give you 2. If n equals 2, 2 times 2 squared, do your parentheses, exponent, PEMDAS, right? 2 squared is 4 times 2 gives you the 8. 2 times 3 squared is going to give you 3 squared is 9 times 2 is 18. And 2 times 4 squared is 16 times 2 gives you 32. That's where those numbers are coming from. The 18 does not happen until the next energy level starts, and that's where people get confused. Okay? That 18 does not happen until the fourth energy level starts, and then you go back and you start to fill in your third energy level. That is called electron overlapping. Now, here's the good news. You don't need to memorize them because they are given to you on your reference table right here. Okay? If I ask you what the electron configuration is for manganese, you tell me it's 2, 8, 13, 2. Okay? Now, that very last ring has a special name. It is called the valence shell. I want you to write that down. You can't see what I'm writing. Okay? This is probably the most important thing I'm going to say today. It is a valence shell. Valence means outside. And the electrons that are in the valence shell are called the valence electrons. Makes sense. So where do we find valence electrons? In the valence shell. So this is nitrogen, and I knew it was nitrogen because it has 7 protons, right? That nitrogen has how many valence electrons? 5. Okay. Carbon has how many valence electrons? 4. And, chlorine has 7. Okay. Let's take a look over here for a second. I want you to look at this column. Column 1, which is called a group on the periodic table. So across are called periods, up and down are called groups, and I will tell you that again when we talk specifically about the periodic table. Look at all the elements in group 1. Lithium, sodium, potassium, rubidium, cesium, francium. What can you tell me about all the elements in group 1 in terms of valence electrons? Adrian? They all have 1 valence electron. Look at group 2. All the elements in group 2 have how many valence electrons? 2. Okay, I'm going to zoom out for a second because groups 3 through 12 are specific types of elements. These are called transition elements or transition metals. We'll look at them again when we get to the periodic table, but we're going to skip over them for a second. We're going to go to group 13. All the elements in group 13 have 3 valence electrons. You should probably be looking at your periodic tables. It's easier to see. Group 14 all has 4. 15 all has 5. 16 all has 6. 17 all has 7. And 18 all has 8, except for helium. Why does helium only have 2 valence electrons where everyone else in his group has 18? Go back to what? This? Yeah, let's draw helium. Okay, so I'm going to draw helium's nucleus. How many protons in helium's nucleus? 2. Okay. How many rings does helium get? No. This is the nucleus. It only has one energy level, doesn't it? And how many electrons are in it? 2. In the first energy level, what's the maximum number of electrons you can have? 2. That's why helium can't have 8, because helium only has one energy level, and that energy level, we're looking at two different things. That energy level is filled with 2 valence electrons. Okay? All right, you see that sheet that I gave you? It looks like this. Okay. Take it out. Let's do some. I'll do the first couple with you, and then you can try some on your own. Does everybody have their paper? Caleb? You need one too? Sean, you need one? Oh. Ah, my foot is stuck. Anyone else?
Oh, Cam needs one.
Cam, you need one too? I'm not having much luck here. There you go. All right. Let's look at this one that says nitrogen. Okay. How many protons does nitrogen have? 7. That's a big 7. It has 7. Okay. How many electrons? Let's skip neutrons for a second. How many electrons is it going to have? 7, because it's an atom, right? We didn't deal with ions yet. We're just starting to work on that. Neutrons, okay, let's take the most abundant isotope. So we're going to get that right off of the periodic table. We're going to take this atomic mass, we're going to round it to a mass number. We'll make it 14, and I'm going to put that 14 down here at the bottom line. I'm going to write nitrogen here, and I'll write the atomic number up here. Okay. How many neutrons does it have? Nope. 7. It has a mass number of 14. So if we wrote it in isotopic notation, it would look something like this. 14 over 7, right? That's what the isotopic notation would look like. Come on. You could do it. Okay. Now, let's draw the Bohr diagram. This is my nucleus right here. That's my nucleus. How many electrons go on the first energy level? 2. 1, 2. How many electrons go on the second energy level? 5. 1, 2, 3, 4, 5. How many valence electrons does it have? 5. Okay. All right, let's do aluminum. What's its atomic number? 13. What's its mass number based on its most abundant isotope? 27. Okay, and this will be aluminum. We've got 13 protons. We have 13 electrons. How many neutrons do we have? 14. Beautiful. Okay. Do you see that aluminum is in the third energy level? It's in the third period. It has 3 rings. On the first ring, you're going to have, here's the nucleus. I'll color it in so we don't get confused. In the first ring, I'm going to have 2 electrons. In the second ring, I'm going to have 8. Please draw them in order. 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock. Then again, 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock. That's the 8 for aluminum. Now, how many in its valence shell? 3. 1, 2, 3. Is this easy peasy lemon squeezy, or are you getting confused? Okay. How many valence electrons does aluminum have? 3. Good. All right, fluorine. Atomic number is 9. And its mass number, we're going to make it 19. Fluorine. Okay. 9 protons, 9 electrons. How many neutrons? Cam, how many neutrons? You don't know? Somebody tell him how to figure out neutrons. Yep, so we're going to take the mass number. Do you know which one's the mass number? Cam, you know which one's the mass number? What? Okay, but I've been doing it for a week, so do you know which one the mass number is? $19. 19 is the mass number. That's the number of protons plus neutrons. Okay? Now, if I take 19 and I subtract 9, what do I get? 10. So that's the number of neutrons. Okay. Now, let's take the nucleus in the first energy level, and this is where coming back to here is going to help us. In the first energy level, how many electrons am I going to place in there? 1, 2. In the second energy level, how many electrons am I going to place in there? 7. Start at 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock. That's 4, 5, 6, 7. How many valence electrons does it have? 7. Okay? So now we've covered drawing simple Bohr diagrams. You just have to look at the periodic table. It tells you. These numbers right here, the 2 plus the 7, will add to this number. Because these are the electrons. This is the electron configuration. And this is the atomic number. The atomic number is the number of protons. The electron configuration tells you how many electrons and where they are. What ring number they're in. The electrons want to be in the lowest possible rings that they can. They want to be in the lowest possible energy levels that they can be in. We're going to talk about that this week too. So if you look at calcium, this is 20 protons. These numbers should add up to 20. Okay, because the protons and the electrons are equal to each other. Any questions on any of this? All right, try the next row by yourself.